Hello students, today we are going to start a new chapter, that is Introduction to Trigonometry. This is the 8th chapter in your NCERT textbook. Okay, without wasting much of our time, directly we will get into the chapter. Listen carefully. You see, while writing, we'll write it as trigonometry, but while reading, we'll keep this O silent and we will read it as trigonometry. So it is trigonometry, not trigonometry. Okay, but while writing, we'll write it as trigonometry. The word trigonometry is derived from three Greek words: trigon, metron, which means three angle measurement. So in mathematics, when we talk about three angle or three side, the figure that comes to our mind is a triangle. As you all know, a triangle has 6 elements, 3 sides and 3 angles. The 3 sides of a triangle are denoted by small letters and the 3 angles are denoted by capital letters. For example, if I consider a triangle, then these 3 angles of this triangle are denoted by capital letters A, B and C, and this is called angle A, this is angle B and this is angle C. In geometry we call this A, B, C as vertex, but in trigonometry we call this A, B, C as angles. Okay, the side which is opposite to angle A is denoted by small letter A, the side which is opposite to angle B is denoted by small letter B, the side opposite to angle C is denoted by small letter C. You can give any other notations, but it must be a small letter, that's all. Okay, now this trigonometry, it deals with the measurement of the angles and the sides of a triangle. So trigonometry is a branch of mathematics which deals with the measurement of angles and sides of a triangle. Once again, trigonometry is a branch of mathematics which deals with the measurement of angles and sides of a triangle. So you have studied in your basic classes that there are different types of triangles, right? But in this chapter, trigonometry, in class 10th, we restrict our discussion only to a right angle triangle. Trigonometry is simply associated with a right angled triangle. It is applicable only for a right angled triangle. In your higher classes, you will study that it is applicable even for triangles which are not a right angle triangle. Earlier, this trigonometry was developed to solve problems related to astronomy and geometry. But now it has a wide application in the field of physics, electronics, mechanics and other branches of mathematics. Scientists like Aryabhatta, Bhaskaracharya, Sir Isaac Newton and many other scientists have contributed to the development of this subject, trigonometry. Okay, as I have already said, trigonometry is applicable only for a right angle triangle. The question arises, what is a right angle triangle? Don't you know what is a right angle triangle? Yes, of course you know, because you have studied about triangles in your basic classes, right? A triangle in which one of the angle is equal to 90 degree is called a right angle triangle, right? Here angle B is 90 degree and angle A and angle C will be less than 90 degree and they are called acute angles. Okay, next, what is this side AC is called as in a right angle triangle? You know, the longest side of a right angle triangle is called as hypotenuse, right? Good. The side which is opposite to this angle 90 degree is hypotenuse. This is hypotenuse, the longest side, or the angle, the side opposite to this 90 degree is hypotenuse. Then what about the other two sides, AB and BC? What they are called as? So they are called as adjacent sides and opposite side. Adjacent side and opposite side. How to decide that this is adjacent side and this is opposite side. Why we can't take AB as adjacent and BC as opposite? Of course you can take, of course you can call this as opposite and this as adjacent, but it depends on with respect to which angle we are talking, whether we are talking with respect to angle A or with respect to angle C. So listen carefully, the opposite side and adjacent side are decided with respect to any one of this angle A and C. If I am talking with respect to this angle C, if I am talking with respect to angle C, then the side AB which is opposite to angle C is called opposite side. Then the other side BC is called adjacent. If I am talking with respect to angle A, if I am talking with respect to angle A, then the side BC which is opposite to angle A will be called as the opposite side. Then the other side will be called adjacent side. Is this point clear to you? Let me take an example. Let us consider a right angle triangle PQR, right angled at Q. Then what is PR called as? Hypotenuse. With respect to this angle P, QR will be the opposite side and PQ will be the adjacent side, right? If I am talking with respect to angle R, if I am talking with respect to angle R, then this will be the hypotenuse. With respect to angle R, this will be the opposite side, QR will be the adjacent side. Is this point clear? So since trigonometry is applicable for a right angle triangle, whenever we solve problems related to trigonometry, we will come across a right angle triangle and we talk with respect to opposite side, adjacent side and hypotenuse. So it is very important for you to know how to decide the hypotenuse, adjacent and the opposite side of a right angle triangle. Okay, in your textbooks you might see the words like hypotenuse, base and perpendicular. Don't get confused. The base we call it as the adjacent side and the opposite side we call it as perpendicular. That's all. So if you learn this way also, it is not going to create any problem. Okay, you can learn this way, or if you are okay with base and perpendicular, you can learn it that way also. Okay, but don't get confused. Next, we will consider a right angle triangle. Let us consider a right angle triangle A, B, C, right angled at B. So now, with respect to this angle A, with respect to angle A, this side will be the opposite side, this will be the opposite side, and since here it is 90 degree, this will be the hypotenuse and the side AB will be adjacent side. AB will be adjacent side. This angle A can be 30 degree or 35 degree or 40 degree. So in general what I will do is, I will consider that this angle A be equal to theta. So theta is a Greek word which is used to denote an angle. So with respect to this angle theta, this is the opposite side, this is the adjacent side and this will be the hypotenuse. Now let us take the ratio of opposite side and the hypotenuse, the ratio of opposite by hypotenuse, which is the opposite side here BC and the hypotenuse is AC. Okay, you can keep a scale, measure this length, measure AC, substitute, you will get a ratio. Fine. Next, let us extend this line AB and AC to get a new right angle triangle. Let me call it as APQ, right angled at Q. Now for this right angle triangle AQP, with respect to this angle theta, you must note down that I have not changed this theta. Without changing this angle theta, I have just extended this line. So with respect to angle theta, for this right angle triangle AQP, PQ will be the opposite side, AP will be the hypotenuse, and AQ will be the adjacent side. Now once again, for this right angle triangle, we'll take the ratio of opposite by hypotenuse, which is the opposite side. PQ is the opposite side and hypotenuse is AP. Once again, let us measure this length. We will substitute and reduce it to the simplest form. So we get a ratio. That ratio what we get here will be same as this ratio. So these two ratios will be equal. Further, if you want, you extend this line. Once again, you take the ratio of opposite by hypotenuse. It will be same. But you must note down that it is for a given angle theta. For this fixed value of theta, for a constant value of theta, the ratio of opposite by hypotenuse for a right angle triangle will be same. If you change this angle theta, if you increase or decrease, then this ratio will change. Okay. The mathematicians, they found that for a given angle theta in a right angle triangle, the ratio of opposite by hypotenuse is equal to sine of angle theta, is equal to sine of angle theta. What is this sine of angle theta called as? This is called as a trigonometric ratio. This is called as a trigonometric ratio. So sine of angle theta, or it can also be called as sine theta. It is equal to opposite by hypotenuse. Like this, you can take other ratios also. See, opposite by hypotenuse is one of the ratio I took. Instead of that, you can take adjacent by hypotenuse, or you can take opposite by adjacent, or adjacent by opposite. Like this, all together we can write 6 different ratios. So we say that in trigonometry there are 6 trigonometric ratios. Out of 6, this is the one, sine of angle theta, or it is also written as sine theta. Which are the remaining 5? So let us see. Next we will study about the 6 trigonometric ratios. Trigonometric ratios, or they are also called as trigonometric functions. Trigonometric ratios or trigonometric functions, or simply we can call them as T ratios. T ratios. Okay, let us consider a right angle triangle A, B, C, right angled at B. So with respect to this angle C, this is hypotenuse, no doubt in that. With respect to angle C, this will be the opposite side. AB is the opposite side, BC is the adjacent side. Okay, now let us write all the 6 trigonometric ratios. First one is sine of angle theta. Sine of angle theta. This is equal to opposite by hypotenuse. This ratio is equal to opposite by hypotenuse. It can also be written as sine theta. It can also be written as sine theta. Sine theta is equal to opposite by hypotenuse. The second one is cosine of angle theta. The second one is cosine. Cosine of angle theta. It is equal to adjacent by hypotenuse. Adjacent by hypotenuse. In a right angle triangle, the ratio of adjacent by hypotenuse is equal to cosine of angle theta. It can also be written as cos theta. It can also be written as cos theta. The third one is tangent of angle theta. The third one is tangent of angle theta. This is equal to opposite by adjacent. This is opposite by adjacent. So the ratio of opposite by adjacent is equal to tangent of angle theta, and it can be written as tan theta. The fourth one is cosecant. Cosecant of angle theta. this cosecant of angle theta is the reciprocal of this sin theta. Sin theta is what? Opposite by hypotenuse. If you take the reciprocal of this sin theta, it will become hypotenuse by opposite. This will become hypotenuse by opposite. And it can also be written as cosec theta. But you must read it as cosecant theta. You should not read it as cosec theta. So it is cosecant theta, but the short form of writing it is cosec theta. Fifth one is secant. Secant of angle theta, that is the reciprocal of cosine. So cos theta is adjacent by hypotenuse. The reciprocal of cos theta is hypotenuse by adjacent side. Okay, and it can be written as sec theta. Last one, cotangent of angle theta. Cotangent of angle theta, that is the reciprocal of tangent. Tangent, tan theta is opposite by adjacent. The cotangent will be adjacent by opposite. This will be adjacent by opposite. It can also be written as cot theta. Okay, these are the 6 different trigonometric ratios. You can remember them as sin theta, cos theta, tan theta, cosec theta, secant theta and cot theta. So here you remember sin theta is not the product of sin and theta. Okay, without this theta, sin has no meaning. Okay, it is sin theta. In the same way, cos theta, tan theta, cosecant theta, secant theta and cot theta. Now, whenever a right angle triangle is given like this, first you must decide the hypotenuse and you have to see with respect to which angle you are writing all these trigonometric ratios. Now, for example, if you are writing with respect to angle A, then BC will become opposite and AB will become adjacent. Now, you want to write sin A. So, what is sin A? Sin A is opposite by hypotenuse. Here, which is the opposite side? BC is the opposite side. AB is the adjacent. AC is the hypotenuse. We want opposite by hypotenuse. So, this sin A will be equal to BC by AC. BC by AC. In the same way, what is cos A? Cos of angle A. Cos A is adjacent by hypotenuse. So, adjacent side is AB, hypotenuse is AC. So, it will be AB by AC. Then you may think, sir, how to remember these ratios? Yes, I am there. Definitely I will help you. There are easy methods, easy tricks to remember them. First thing that you must know is you must learn them in the same order. Okay, sin theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. If you know first 3, then the remaining 3 can be written, because cosecant theta is the reciprocal of sin theta. Cosecant theta is the reciprocal of sin theta, and secant theta is the reciprocal of cos theta. 1 by cos theta is equal to secant theta. 1 by sin theta is equal to cosecant theta. In the same way, 1 by tan theta is equal to cot theta. And see, cosec theta into sin theta will be equal to 1. In the same way, the product of sec theta into cos theta will be equal to 1. Cot theta into tan theta will be equal to 1. So first you must remember in the same order: sin theta, cos theta, tan theta, cosecant theta, secant theta and cot theta. Now, if you remember them in this order, then to write these ratios, you must know this. See, you must remember them like this: old, ors, always remember, is owner's, approach. Funny, right? Old ors always remember his owner's approach. So opposite by hypotenuse. See, opposite by hypotenuse is sin theta. This is for sin theta. Adjacent by hypotenuse. Adjacent by hypotenuse is cos theta. And opposite by adjacent is tan theta. So if you learn them in this order, and if you know this, then you can write all the 6 trigonometric ratios. This is how you must remember. This is how you must always say. Old ors, always remember is owner's approach. Then this is for sin theta, this is for cos theta, this is for tan theta. If you want cosecant theta, the reciprocal of this. If you want secant theta, it will be the reciprocal of this. If you want cot theta, then it will be the reciprocal of tan theta. Okay, is it clear? Along with this, you must know 2 more ratios, that is the ratio of sin theta by cos theta is equal to tan theta. Sin theta by cos theta is tan theta. In the same way, cos theta by sin theta is equal to cot theta. Okay, hope you understood all the trigonometric ratios. Now you know how to write all these 6 trigonometric ratios. Fine, then it's good. In the next class, we will see how to solve the problems related to this. Okay, this is all for today's class. Thank you. Love you all.